Okay, good afternoon, friends. In previous lecture, we already covered the resolution and we also take some numericals. And today we will going to discuss the types of error. And after this topic, we will see some formulas uh, related to this error analysis. For example, average value deviation and this all. So the definition of these terms you can refer the AK Sawhney book. Okay, I directly take the formulas and you already study uh, this basic formulas in your 12th. Okay, so the only difference is that these terms is related with your error. Okay, so when we use that formulas, so we our intention to find out the error. Okay, now uh, when I talk about the types of error, the whole error is divided into three categories. First is gross error, second is systematic error, third is random error. So in systematic error is also divided into three categories. First is instrumental error, and second is observational error. Okay, third is environmental errors. Okay, so we will see what is that. So this systematic error is divided into three categories. And now, when I talk about the gross error, in gross error, these are the completely due to the human mistakes. Whenever you go in a laboratory or in industry, when you take the reading, a person is taking the reading, whatever the mistake done by him, that that is a responsible for this gross error, or you can say any human negligence error occurred in your reading, that comes under your gross error. Now uh, okay, so this is not a constant error, because this depends person to person. So you can say that this gross error is nothing but your variable error. So it is a type of variable error, and it is depend person to person. Okay, so to avoid this gross error, generally what precaution we need to take? The reading can be taken correctly from the meter when the meter is in vertical position and your eye contact should be over the pointer. Okay, that means your contact of eye with that reading of scale make an angle of 90 degree. Okay, 90 degree of to the meter. So you must take this precaution while taking the reading, so you can uh, uh, able to eliminate this gross error. Okay, when I talk about the systematic error is divided into three categories, right? Instrumental error, environmental error, and observational error. Now uh, this error generally present this error is always present in your meter. Okay, uh, so but you need to take care of that. This error should be not very big, or you should restrict that error as possible, me- means minimum as possible, right? So, instrumental error is due to the inherent short of coming of instrument. After sometimes there are also you find out this aging effect. That's why we are placing the damping is slightly greater than critical damping and slightly less than of under damping. That's why after some time, due to this aging effect, your instrument means that damping will become under this critical damping, right? When you put the damping above the slightly above the critical damping, after sometimes the edging effect, due to this edging effect, that damping will be equal to the critical damping, so your accuracy may not lose. So, and frictional error, hysteresis error also are there. So these are the, you can say, depends on every instrument. Okay. And misuse of the instrument, choosing the wrong scale of the instrument. If you choose the wrong scale of the instrument, so whatever you want to measure, that reading, if comes falls under the nonlinear scale, then also you lose the accuracy. So you must take care of this. uh, for avoiding this, you always choose the best possible scale of the meter for measuring the quantity, respective quantity. Okay. So that's also this parameter also plays a key role for eliminating the this instrumental error. And third is loading effect. And some more error also comes under this instrumental error. For example, limiting error, guaranteed accuracy error. This all error comes under the instrumental error. Okay. Second is that environmental error. So yeah, as you know that uh, in India, or in any in India, basically in India, there are not a there are different types of weather conditions, right, at different locations. So if you see at different location, the meters also act differently. Okay. So we must take care of that. And at that time, when you take the reading, you must consider all these factors. So which factors affect your reading? First is due to the temperature differences, right? And pressure, humidity, dust, that's all factors are comes under this environmental error. So you must be take care of that also. Okay, because the season by season in weather condition is changing, and due to that, the meter is made up of some different parameters. Aluminum index are there, some depending on the meters to meters, PM, Siemens meter, MI instrument. So that all meters are it has their own property, right? So that is vary with the weather conditions also. So you must be take care of that. And this is after time to time, you must be maintain all the meters. So you can be eliminate this environmental error also by considering these all factors, right? Now, one more error is observational error, and it is also called as a parallax error. Okay, now observational error or parallax error is nothing but the uh, error due to the human negligence. Okay, but it is common to all humans. If you for example, if you see the different types of meters are connected in your rail, right? Railways, rail engines. Okay. So uh, for example, in a train there are different types of meters also is there in your train engines, right? So if if someone want to measure the reading, so nowadays there are digital meter also are there. So it is not very difficult to take the reading, but in earlier days it is very quite very difficult to measure the reading, right? So at that time, there are this observational error is also are there. For example, See the pictures. Wait. Now see, if your meter is located in such a location where you are not able to go and observe your reading correctly or so comfortably, so at that time this error will be occurred. For example, now see the scale. So how to eliminate this error? So see, this is your pointer and this is your pointer shadow. This when you observe the reading, you are you can take when you observe the reading, this shadow should be not visible to you, then only you can say that you are taking the a good reading or accurate reading. Okay, so that is nothing but your parallax error, or you can say observational error. Now I am when I look that your scale, I observe that this pointer is lies on this scale, right? But when you observe a such a way that this pointer and your eye contact making an angle of 90 degree, then this shadow will be not visible to you, then you can say that this observational error you can eliminate it. Now, depending on the different location of meter in industry as well, for example, in in thermal power station, the boiler are there, right? So there also are different parameters, different meters are there installed in different locations. Nowadays, it is easy to measure, but in earlier, the temperature at near the boiler is very high, right? So it is quite very risky and difficult to take the readings from that. Okay, so at that time, these such types of error are occurred in your meter, not in your meter. This is a human negligency error, and this error is constant for all. Okay, if I go to that meter and take the reading, it is is it is constant for me. If some other also go to take the reading, that error is also constant for them also. ओके, ये सभी के लिए कॉमन ही होगा. ओके, now I hope this is observational and parallax error is clear to you all, right? Now, the random or accidental error. Such types of error is occurred on your meter and suddenly goes off. Okay, so we don't know from where this error is observed on meter, but you are finding that some of the times some error is occurred, but that error is goes automatically. You are not doing anything else. So such types of error is we are putting in this random error or accidental error. So these types in this such types of uh, these types of error is put in these random errors. For example, average values. If you take the number of readings from x1 to xn, so you are taking the n number of time reading, and yeah, for each time you will get a different value for a constant measurement, right? See, read out these all definitions. This is the due to the unidentified sources, right? These errors come suddenly and eliminate suddenly, but reason is not known. These are the more, but effect is very less. Okay, to eliminate random error, statistical analysis is carried out. So, under this random error, different statistical parameters are there. So, we are using that parameter for analyze your readings. Okay, which are the same input, right? I also told you the your input is same, but at each time you will get different reading, and that reading is slightly means deviation of that reading is very less, but still the error are there. So you need to find out that. measure under the number of times with one of the instrument by the one observer or many observer. So this reading you are taking from n number of times. So in that you can familiar with this terminology, right? You already study in your mathematics subject in your 12th and your first year and third sem also, right? So average value is sum of all reading divided by number of terms, right? So it is denoted by this x bar. And deviation is nothing but your deviation from your this average value. Okay, for example, this first reading you will get something, and what is the average value you will get here. Take the difference of these two. Now deviation may be positive and negative, right? Deviation may be positive and negative depending on your taking the reading, right? And the average deviation is nothing but the sum of your all deviation divided by number of terms. Okay, you need to take the determinant of that, or sorry, you need to take the mode of that. So in average deviation, you are taking all of the reading, and when taking the average deviation, please note that you need to take the mode of all these readings. Okay, uh, to why we are taking this average deviation is to know the precision of the instrument. I already explained what is the precision, right? Standard deviation. This standard deviation, this is a deviation from the average value. Okay, deviation from the average value, and its formula is, it is denoted by this sigma. Sigma is nothing but your under root of some square of the deviation, sum of the square of the all deviation divided by number of term n, or you can say number of term, right? So this formula is valid when number of terms, or you can say number of readings are less than 20. Okay, and if number of greater than 20. Okay, when number of scale is number of observation is less than 20. Okay, so then you are using this below formula, which is sigma is equal to under root of, numerator is same, but only difference is that here you need to take n minus 1. Okay, here you use n, but when n is less than of 20 you need to take n minus 1. And this is a probable error, which is nothing but your plus minus 0.6745 sigma. This is you will get this error by the by experimental setup. Okay, so you are directly note this. And if you want to please note that if you want to the definitions or some more information, I am directly pick up that content which is very useful from you. Okay, so for details, better to refer the ADK Sony book. Okay, so now sixth one is probability error of a mean, which is represent this RM, R suffix n, which is nothing but your R divided by under root of n minus 1. So by using all these formulas, I can frame a questions in your exam. Okay. Now this is uncertainty error. It is defined as a function, a reading. You are measuring a reading, right? That reading may be a function of x term. So here there are different types of uncertainties are there, which is represent with wx1, wx2 up to wxn. That uncertainty can be represented with the help of this formula by taking this square root of these readings. Okay, so this is already given to in your questions. You need to just use that formula and solve this, so you will get this uncertainty. And this standard error also, if the this sigma is if you if the reading is a function of x, okay, so overall x you can find out by this taking this different the standard error with each possible error, right? For x1 is sigma x1, for x2 this sigma x2, for up to xn this for sigma xn are the standard deviation error of your respective reading, right? So put that all value in these equations, you will get this standard deviation error. Wait a minute, guys. Hello. Okay. Yes. Now, one more thing. Uh, we already see different types of error. Okay, whenever we do the calculations, there are some concept how to solve that. See here, this is a resistance 1 is given to you, which is R1 100 plus minus 4 ohm. So this is denoted or defined as your deviation, right? Or you can say tolerance. So this is your deviation, right? This is our same, this terms is given to, this terms is, this terms is given in ohms, right? Not in percentage. So in such a case, when the readings when the error, or you can say when the deviation are given to you in terms of their absolute error, right? This is called your absolute error. Okay. Now at that time, when you add these two quantities, then this error is directly added. Okay. When when we take the division and multiplication, then we will see that also in slide. Okay. Now see, in case of this addition and subtraction, the absolute error will be add. Okay, so this is the absolute error denoted in terms of this ohm. Now, so what is the possible reading of this is 100 plus 4 and 100 minus 4. So this is 104 and this is 96, right? This is a possible range of this your R1, right? Under this is your possible range of this your R1. So this error is defined in terms of ohm. So if it is defined in terms of percentage, then you need to calculate in terms of ohm. Okay. Now I am adding these two readings. Simple. When you add or subtract, now I am adding these two readings. This is 100 plus minus 4 ohm, 50 plus minus 4 ohm. This is directly added, and this absolute error at any condition, either addition or subtraction, this absolute error will always be added. Okay, then that's why this 4 plus 2 is 6, and this is addition, that's why 100 plus 50 is 150. When I take the subtraction of these two reading, 100 minus R2 is 100 plus minus 4 minus of 50 plus minus of 2. When when I take the minus of this, so this 100 minus 50 is 50, and plus, and this reading also always add. Okay. Now in case of multiplication and division, percentage error will be add. Okay. Now observe the at what observe the reading which is provided you. uh, that reading, if given to you in terms of percentage, then and you are doing the calculation with multiplication and division, then it's okay. But if the reading is given to you, and that error will be represent in terms of unit, that is ohm, or different for this resistance is ohm, right? Then at that time you need to convert that error in terms of percentage error. Okay. So here when you take the this multiplication, simple, directly take the multiplication of these two reading. So in that you are always add this percentage error directly, right? 4 plus 2 is 6%, and multiply these two terms. So this is your error. When I take the division of these two readings, so same concept, this percentage error is directly added, and divide this 100 divided by 50 is 2. So 2 plus minus 6%. So this two concept is very much important when you solve uh, your numerical problem. Okay, now see some example I am taking here. I hope you can solve it, and try to solve it with me. Okay, I'm also solving this question, and you can also try this question. Okay, here you need to find out the R equivalent. So these are the two resistances given to you. Guys, please solve it and tell me what you will get. So what is R equivalent here? See, R equivalent, these two resistance are connected in parallel, right? So you need to take the parallel combination, which is nothing but your R1 R2, right? R1 R2 divided by R1 plus R2. Okay, now see, this reading, this resistance is given in terms of absolute error, right? So see, in addition or subtraction, you don't have any trouble, right? But here multiplication also is there in your R equivalent. So you need to convert that scale into the percentage error. Okay, this absolute error you need to convert into the percentage error. So write R1 in terms of percentage error is, what is the uh, what is the value of this percentage error? Now see, full scale value, what do you mean a full scale value? Which is given here, right? And you this deviation is given to you. So I can say that this is your x percentage, right? X percent, which is nothing but your point one. ऐसे ही निकालते हैं हम, राइट? लास्ट क्लास में हमने देखा था. So when you solve it, this 100 and this is cancel out. So this x is nothing but your point 0.1 percentage, right? This x in terms of percentage, you will get x in terms of percentage, right? So what is the reading scale of this R1, or this R1 is nothing but your 100 plus minus of 0.1 percentage. Okay, now R2, similarly find out this R2, and guys please response. Yes guys, किसी को आंसर मिला तो बताओ, R इक्विवेलेंट कितना है? R2, what is the R2? Sorry, please repeat. R2, yes, R2 also is 0.1%. Same way you can calculate it. Okay, now, yes guys, put that value in this equation and find out this R equivalent. Find out this R equivalent. Simple. This is what is your R1. R1 is, guys, please do the separate calculation. So you will be not be confused while doing the calculation. This problem, right? So ये R1 का 100 है, and this is R2 50. So 100 plus 50. This is one side. Take the plus minus. When you multiply these two reading, use this two, right? When you multiply these two, then use this percentage value, which is zero point 0.1 plus zero point 0.1 is 0.2 percentage, right? When I take the addition, so you need to take this reading, which is 1 zero point 0.1 ohm and zero point 0.5 ohm, right? So which is nothing but your 0.15 ohm, 0.15. Now now when you solve it, so कितना आता है ये 5000, right, divided by 150, solve it, you will get this. Now see, this is the division, right? So this is the division, and this denominator reading in terms of your absolute error, right? This is a deviation that is 0.15 ohm. So you need to convert this denominator in terms of percentage. So do one more calculation here. For converting this scale, you need to convert this scale into the percentage. So when I take the percentage calculation, so this is your 150 into x percentage, right, is equal to 0.15. 0.15. Okay. Now solve it. When you solve this problem, so you will find this x percent is nothing but your 0.15 divided by 15 multiplied by 10, right? So this is cancel out, this is zero point 0.1. When you multiply, you will get 1. Is it calculation is correct? 150, 0.1%. Point. So here is a 150, 150, 150 divided by 100, 1
The
cancel.
point one होगा.
Yes, yes, point 1 होगा. Okay. So 0.1% यहाँ पे भी आ रहा है, ठीक है? तो put that value in this. So this is your 5000 divided by 150. 150. This term is constant. Only the variation in this error part. Okay, सिर्फ error part में variation होगा depending on this steps. यहाँ पे divide हो रहा है, so this term is also in terms of your percentage. So this terms is nothing but your 0.1%. 0.1 percentage, right? This is your 0.1%. Now, yes guys, इसको कैलकुलेट करो कितना आता है. This is zero point 0.3, right? Division
It's
में
33.33.
how much?
33.33.
Okay, 33.33. So this is your error. Okay, this is your required resistance, and this is the percentage error. Now convert also, represent that error in absolute terms. So the same way you can represent or find out this absolute error. So 33.33 multiplied by zero point 0.3 by 100 is equal to how much? And take this y variable. कितना आता है इसे सॉल्व करो. When I solve this, so this is nothing but your 0.33 divided by, हाँ, 0.9, 0.1 आता है ऑलमोस्ट. 0.1 आता है क्या?
Yes, sir.
So this is your absolute error, right? So this reading is 33.33 plus minus point 0.1 ohm. ओके, सो इतना डेविएशन रहेगा आपका एक्चुअल रेजिस्टेंस की रीडिंग में, आर इक्विवेलेंट. सो दिस इज योर एक्चुअल वैल्यू एंड दिस इज योर एरर पार्ट. ओके, सो बाय दिस way you can find out your error analysis. Now, yes guys, so you need to take care of this concept. When you multiply these two terms, your possible or your uh, error given to you, should be that must be in percentage type, right? Then only you can add that error. When you doing the calculation in terms of plus or minus, then that at that time absolute error will be added. In the same way, you need to convert this error part depending on your these calculations. And this terms is somehow constant in all times. Only the change is happening in your error part. Okay. Now, this is one more question. Here, the galvanometer is connected between these two ports, and the current is showing is 0 ampere flowing from this side. So, what it means? It is a balance bridge, right? Because this potential and this potential is same, then only the current is zero. So, under the balance condition, you need to find out this R4. So, under the balance condition, what is the criteria or what are the steps you need to use here is R1 R3 equal to R2 R4. Okay, now use the same concept. Here the reading is given to you in terms of percentage as well as in terms of absolute error. Okay, so you need to convert that error part in terms of absolute or in terms of percentage depending on your calculations, and try to find out this R4 the same way which we already do this problem. You can also solve this problem, and please solve it and tell me what is R4, what you get. Put that all values here and solve it. 100 plus minus of 2%, and this R3 is 20 plus minus of 2 ohm, which is nothing but your 50 plus minus of 3%, and this is your R4, right? So R4 is nothing but your this 100 plus minus 2%, and this is 20 plus minus 2 ohm divided by 50 plus minus of 3%. Solve करो उसको. एरर पार्ट को अगर मैं छोड़ दूं, ओके, फाइंड आउट दिस. ओके, आई एम जस्ट solve it. 100 into 20 divided by 50, so 50 to the plus minus of your error part. Okay, so when you solve it, you will get 40 plus minus of your this error part. Solve this error part. So इतना आएगा आपका. Okay, do this proper calculations which I have. This is nothing but your 6 ohm. Okay, 6 ohm. This is plus minus 6 ohm. Try to find out and match your answer. Now there are some more example I want to take it and use that all numerical formulas which I discuss here, this average value deviation, average deviation, use that formula in this question. First of all, try to solve it, and if you have any problem, please ask. Yes guys, use, किसी को मिला 6 आया सबका? परसेंटेज कितना आ रहा है बताओ? परसेंटेज एरर कितना आ रहा है?
15%.
Yes, 15% is right answer. uh, Write one more question. The following 10 observation are given to you. Okay, 10 observation is given to you. You need to find out the mean, standard deviation, and probable error. Okay, so 10 observation are there. So this is your own question. Try to solve it. This is a number of observations, and this is your scale of reading. So this is your one, which 41.7. Second is 42. Third is 41.8. Four is 42. Fifth is 42.1. Sixth is 41.9. Seventh is 42.5. Eighth is 42. Ninth is 41.9. And tenth is 41.8. So these are the different scale of reading is given to you. You need to find out here. First is mean. Okay, you need to find here. First is mean. Second is standard deviation. Second one is you need to find out standard deviation, deviations. Third is probable error of one reading. Okay, so you need to find out these three parameters. So here, probable error of one reading means better to use here standard deviation. Okay, so what जितना भी standard deviation आएगा, you need to find out this probable error for this standard variation. Okay, so first of all, find out these two value with this scale of reading, and then find this probable error. Try to solve it. You need to use that formulas. First of all, which formula you use for calculating this mean? Mean is nothing but your, see here, sum of all the reading divided by number of scales, right? That is your average value. So average value is here nothing but your mean of that. Now, for second one, you need to find out the standard deviation. For standard deviation, this formula is used, right, because the number of observation is less than 20. So use this formula, standard deviation. For standard deviation, you need to know this average deviation, sorry, deviation from each side, right? So you need to find out this deviation. Once you find out this mean, or average value, right? So try to use these three formulas and put that value in your formulas. And third is probable error. For probable error, you need to use these formulas, okay? Which is nothing but your plus minus 0.6745 into sigma. This sigma is nothing but your standard deviation. Okay, सॉल्व कर लोगे ये प्रॉब्लम? यस गाइस, प्लीज रिस्पॉन्ड गाइस.
Yes.
Okay, so take one more example as your homework. So take it as your homework. Okay, homework problem. आज हमारा ये यूनिट खत्म हो जाएगा. ओके, इन नेक्स्ट क्लास tomorrow, right? Tomorrow we have scheduled our class at I think 10 a.m. So NBA committee will also visit that class. So I will start your new chapter. Okay. So today we will over this chapter. Today, tomorrow we will start our second chapter. So one more question here. See, the limiting error for the limiting error for a 4 dial resistance box R. So there is a digital box which is given to you the probable error of that different places, which is for unit place the probable error is plus minus of 0.2 percentage. For 10th place is plus minus of 0.1%. For 100 place plus minus of 0.05 percentage. For 1000 plus minus of 0.02%. So if the resistance value is set as 4325 ohm, you need to calculate the limiting error for this reading, for this value. Then tell me how to solve it. So these are probable error is given to you, and what you will get at your output this 4325 ohm. Okay, इतना आउटपुट आपको मिल रहा है. So सिंपल है. All probable error is given to you, and your full scale is also is known to you. So simple है. That is 4325 is your reading, right? So this is your unit place, right? Unit place. This is your 10th place. This is your 100 place, right? And this is your 1000 place. So according to your question, what is the probable error is? This is for unit place is 0.2 percentage, right? Plus minus 0.2%. For unit place is 0.2% plus minus. What is a 10th place is 0.1%. This is nothing but your plus minus of 0.1%. And for 100 places plus minus of 0.05% plus minus 0.05%, and this is your plus minus 0.02%, right? Yes, plus minus 0.02%. So itna percentage error is given to you, right? So percentage error आपको दिया हुआ है, right? If I want to calculate absolute error, तो same way This is 1000, right? This is 1000 reading. So I can say that this 1000, this is a 4000, right? 4000 into percentage error is 0.02%, which is nothing but your absolute error x value. So कितना आता है इसको सॉल्व करने पे? ओके, सो 4 2 80 राइट, 0.8 आएगा, प्लस माइनस ऑफ 0.8. So this is your absolute error, right? So what is a, so this is a plus minus form. So this whole टर्म हाउ टू एक्सप्रेस इट, कैसे इसको एक्सप्रेस कर सकते हैं हम? 4000 प्लस 300 प्लस 220 प्लस 5, ऐसे एक्सप्लेन रिप्रेजेंट कर सकते हो, राइट? And this is given in terms of percentage. So first of all, this is the addition of all these place of quantities, right? So this is a percentage, so you need to find out this absolute error. Okay, absolute error find out करने के बाद ये सबका absolute error आप find out कर लोगे यहाँ पे, इसका भी and इसका भी, okay, इसका भी. Then you need to add this all absolute error, because for making this 4325 you need to add 4000 plus 300 plus 20 plus 5. So each this quantity has some error which we are finding here. Now that is absolute error. So at last you need to add this all quantity, all four quantities. So you need to also add uh, all these four quantities, because we are performing here addition. So what you get at last is 4325 plus minus of addition of these all quantities. Okay, addition of these all quantities. समझ गया क्या बोला मैं? Yes guys, this is clear to all. सॉलिड, सॉल्व करो और जितना आता है यहाँ पे देख लो. ठीक है, फाइनल आंसर नहीं है मेरे पास इसका. सॉल्व करो. So one more example I want to give you as a homework. ट्राई करो, जब तक इसे सॉल्व करो बताओ कितना आंसर आंसर. Yes guys, take one more this as your homework. A 200 volt PMMC voltmeter. PMMC means this is a one of the type of meter that is called permanent magnet moving coil voltmeter. Okay, permanent magnet moving coil voltmeter, PMMC meter. Okay, we will also see that this PMMC meter. Okay, in our chapter number 3, this PMMC meter is given in your chapter number 3, or you can say module 3. Voltmeter is specified to be accurate within plus minus of 2% of full scale. The limiting error, this is your limiting error. Okay, when the instrument is used to measure a voltage of 100 volt is now see 200 pms 200 volt PMC voltmeter is specified to be accurate within 2 plus minus 2% of full scale. Now full scale, this error is respect to your full scale reading, so I can say this is your guaranteed accuracy error. Okay, so you need to find out the limiting error when the instrument is used to measure the voltage of 100 volt. Okay, so in earlier case you are using the voltage 200 volt, but in second case you need to find out your this limiting error for your 100 voltage reading. So I already take such a problem in previous classes, and also we are also see the relation between guaranteed accuracy error and limiting error. Okay, by using that two concept you can able to find out this scale of reading. Okay, and tell me what you get here, कितना है इसका? Yes, please. Yes guys,
2.99.
how much? Yes, anyone guys, किसी को भी नहीं मिला क्या?
So 1.98.
1.98, is it? Yes guys, please. 1.98 इतना मिला क्या?
So 0.9.
किसी का भी नहीं आ रहा क्या? डिफरेंट डिफरेंट आंसर बता रहे हो आप. ओके, 0.98, इज इट?
Yes, sir.
ओके, सो गाइस देख लेना इसका कैलकुलेशंस. इसका 0.98 बता रहे हो आप. 0.98. ओके, नाउ द सेम वे you can find out this answer for this question. Okay, answer for this question, uh, which I have. uh, I have this answer is plus minus of 4%. Okay, चेक कर लो इसका आंसर कितना आता है क्या आपका. If you have any problem, so I will clear this later. Okay. Yes, guys. So our unit number one is completed, and only things is that you need to practice more question, and whatever the formulas I am taking here, that all comes under this uh, s- random error. Okay, so depending on the problem, you need to use that these formulas, and whatever the this topic, or you can say whatever the topic I'm reading here, and I'm simply take the conclusion and the pick up the important points from your book. Okay, so if you want more information about that, please go through that book जितना हमें चाहिए for understanding that topic. So I am take only this that part. If you want read more, so use that book. Okay. Yes guys, किसी को कोई प्रॉब्लम टिल नाउ फॉर यूनिट नंबर वन? If you have any problem, please ask. Otherwise you can go now.